Today I'm going to be talking about satellites, uplinks, downlinks, satellites in the sky, and we will also, down here at San Clemente, be re-aiming this uplink from one satellite to another because we have to transition. So, and I am going to bring you along with me. Let's get things started and pull out tools to get this re-aimed. But first, let's talk about satellite dishes, the actual physical equipment, because this is common across uplinks, downlinks, whether it's, our KU band uplink, a C band uplink or downlink, or DirecTV. All of them are basically the same for all intents and purposes. You have the big dish part. That is your reflector. And all this is doing, it's just like, think of it like a mirror. It's taking that signal that's really far away in a geosynchronous orbit above the Earth, and it is focusing it, it's reflecting it into this part right here. Which this is called the LNB, and it's got spiderwebs on it. There. That is the LNB, low noise blocker. And what that basically is the antenna. I mean, this whole assembly is considered the antenna, but that's kind of what receives that reflected radio waves and converts it to electrical and then comes down the cable back. Now, in our case, which is also an uplink, we have basically an amplifier, which is taking from inside. We have a transmitter, for all intents and purposes, that puts the right RF, very low RF, onto a cable that comes up here. This creates the higher powered RF and pushes it into that little nose cone part right there, shoots it onto the reflector, which reflects it back up to the satellite. So this is a kind of a two-way street for this antenna system here. For all intents and purposes, this is common to all satellite dishes. So those are the major parts that we have. Some of the things that we have to pay attention to is not just our aiming, our azimuth, but we also have to look at our elevation, how high up and down we are according to the horizon. And also our polarization, which is basically a rotation of that little antenna there onto the reflector that goes up. So if we are not rotated correctly, we will not, have the best reception, but if we're transmitting, we are going to be interfering with two sets of traffic. Basically, the polarization that we are, let's just say for this conversation, vertical. Well, you can have somebody else on horizontal as well, or an adjacent person at horizontal. And if you're not correct, if you're not on the vertical, if you're like 45 degrees, for example, you're interfering with the vertical person as well as the horizontal person. We don't want to do that. Interference is bad. So we have to make sure that our polarization is correct, whether it's vertical, whether it's horizontal. It might be like this depending on the curvature of the Earth and where we are on the Earth. This is where we know what the satellite is supposed to look like on a spectrum analyzer. We have a different tool too that I'm borrowing from our satellite provider. This will tell us that we have the peak signal really big wrenches. Okay, this is our test equipment that we have here. This is the XR3 from Applied Instruments. This is the loaner device from our satellite provider. Thank you, Link Up Communications. It's got two ports in the back. We have a port for the indoor unit and the outdoor unit. This goes to the LNB. That provides power in that direction. This goes to the inside. No power in that direction. Okay, I'm looking for SES-2. That's our new satellite that we're going to be on. Sun's starting to come out now. Okay, so I have a little intercept port here, service port, I guess, that takes the cable that comes from the inside the building and basically comes up to a port that I can tap into. So that's what I'm doing right now. I have the XR3 here. Let's turn it on and see. We're just coming out of what's called sun fade. Let's say you're looking down a telescope and You have a light behind the thing that you're looking at, and that light comes right behind it. That's basically what sun fade is. The sun gets right behind the satellite and basically just overwhelms the reception here. Let's see if I can see the satellite that we're currently on. So I can see that my signal strength is actually coming up as the sun is now exiting from behind the satellite. So now we need to go to SES2. We're going from SES3 to SES2. I'm going to bring up an app that I have here. So this is an app called Dish Pointer Pro. With Dish Pointer, as soon as it figures out where I'm at, what I can do is I can hold up my phone and it'll show me in the sky where I'm at. So right now we're pointed at 103 degrees west, which is where SES3 is. And I need to come over and down just a hair to 87 for SES2. Let's get closer. Day 2, and yesterday, how I left it, well, yesterday I got myself in trouble. I kind of oversteered the dish. Loosened up too much, opened up too much, and kind of went whoosh, a little bit too far. So the key is small adjustments. Small adjustments. Small. I did not do small adjustments. I did macro adjustments, not micro adjustments. That's important. Okay. So at the end of yesterday, where I left it, I was locked on a known satellite. I was locked on Galaxy 10. Okay, I know where that is. So if we're looking at the arc, the satellite, geosynchronous satellite arc, like let's say SES3 is here, Galaxy 10 is here, SES2 is going to be right here. So I'm right here. I just need to come over and down. Hopefully, that's all it's really going to be. But again, small adjustments. Let's do a little bit. Look, see where we are, and then go from there. Okay, I have my comically large wrench. Let's loosen things up here a little bit. Okay. So I kind of have to think about this. The way that this is going to work, it's going to push the dish in left or right. So if I need to push the dish that direction, which is where I need to go, I want to loosen this side. No, loosen that side and use this side to push. I don't know why this is so hard for me right now to think. Okay, I figured it out. So, this side, I use this to push. Not push, but basically I will turn this, which will force this rod to go this way, which will turn the dish that way. So loosen this one. All right, I think I got it this time. I think I got it. Minus 45, 46. So I was given some advice yesterday that if I couldn't point it, I basically walk it into that right satellite. So I think that's what I'm gonna have to do now. I tried to go straight from Galaxy 17 to SES3, which is the 2 satellites over. Couldn't do it. So now I'm on Galaxy 28, which is the next orbital slot over, the next satellite over. I've got a lock on that. So let me adjust my elevation just a little bit, see if I can lock onto that satellite, and then from there, we'll have another known position. We'll gently nudge it over to SES2, hopefully. Good morning. Welcome back to San Clemente. Day 3 of dealing with this satellite uplink. So, I discovered... Hi, I'm down here. I discovered that our DMD-20, which is our modem, kind of like the transmitter or exciter, is dead. I brought our backup one because our backup uplink in Santa Ana, the Buck, which is kind of like the transmitter, that one's dead. So in the meantime, let's put this guy in here. So that way we can get this uplink up and running. Probably the worst connector. Next to that is an N connector. Again, those threaded connectors like that, yeah, they may be great for making sure there's a tight seal, but man, what a pain. What a pain. Now I need to call the NOC, see if they can help me. I'll put it on speakerphone for you. Do a cross pole because I just moved from SES3 to SES2. Yeah, I appear to be peaked on it right now based on the downlink side of things, and so... Okay, so that was my initial call to our link up NOC. They're going to call SES. They're going to get all their analyzers set up, get things ready to go to look at our signal to make sure that everything is good and happy. And then we should be good to go from there. They're going to call me back in about 5 or so minutes. So until then, I'm going to go retreat to the shade because it's getting kind of warm out here.
Being said, I guess I get you conference in with SES America.
Okay.
I have your channel lineup sheet here.
Okay. Just got off the phone with the NOC and with SES, and we tried to bring up a carrier wave. So usually, when we're transmitting data, it's data. It's like a modem, you know. If you look up modem noise, it's kind of like that. So it's all this data. It's a kind of a wider carrier, basically. When we do tests like this, when we do cross pole, we do what's called CW, so it's just a single tone, basically. With that, we turn that on. SES didn't see it. Link Up didn't see it. I'm pretty certain I'm on the right satellite. The satellite finder says I'm on the right satellite. And now I'm gonna wait for them to call me back, and we'll go from there. Let me walk you through the air chain of a satellite uplink. So you have your audio encoder, at least the way our satellite uplink works. You have your audio encoder, which creates, I believe it's an ASI stream, like a digital stream. That goes into the modem. The modem is like the exciter, creates the RF, spits out a little bit of RF into a cable, into the Buck, block up converter, basically the transmitter, essentially. That will put it on the right uplink frequency, will spit it out into the reflector, which then goes 22,300 miles up over the equator. From there, it basically gets repeated, put onto like another frequency, downlinked to a receive antenna into a receiver, and there you go. So, okay, all that. I think my issue is going to be at the Buck, the transmitter. So I just tested out of the back of the modem. The modem is putting out power. I do see carrier wave coming out. If that's not the issue, then I'm gonna have to test my cable. And if that's the case, I may have to pull new cable. I hope not, but that is a possibility. So I have to go back to the office. There's a handheld little terminal device that I need to grab for that I can connect and see what is going on inside of it. And then once I get that, maybe, we should be good to go. What a project. God, I thought this was going to be easy. I thought, okay, aim the satellite. There it is. Go. No. Okay, hopefully this is the last day that I'm going to have to be dealing with this project. But here is the little terminal, the handheld terminal, that does connect to this guy and lets me configure settings and read settings and all that fun stuff. So let me get this connected. I will give our satellite provider a call, and then we'll go from there. Fan error, fault. Oh, that's not good. Now it's time to call, link up, and see if they can help me diagnose why this isn't transmitting. Okay. I had to kick the fan around a little bit to get all the baby spiders that were in it off, because I don't want that in my car. No, that is not going in the car. So, had to kick that around a little bit. Let's go to Micro Center and let's go get a replacement fan. Hopefully they have one. And then we'll come back. We'll put the fan back on. We'll see if it fires up. The thrilling conclusion to the satellite issue. I hope this is it. I'm tired of dealing with this project. Gah! All right, so I have a fan for the Buck. We'll put it on here in just a moment and then see if we can get it to make power. Here we go. Fan is on, you can hear it. So you can hear it now. Now to plug into the M&C port. And let's see what it says. Starting MS-DOS.
We've got a client that is going to be moving from transponder or SES3 to SES2. Okay. So they're going to bring up a carrier on SES2 so they can port all of their affiliates over to that and then shut down the SES3 uplink. I wanted to have you guys take a look at it, make sure that it looks good, and you sign off on it. Okay, is there like a lineup document associated?
We tried to turn it on, it didn't come up. It says I'm on the right bird. So the only thing I could think of is that our Buck, the amplifier, is not working.
17, 2, 1.
Okay, so for sure.
7, 6, 8, 8P.
We finally got it. I think we're on the satellite this time. I think. We just turned up, tested with our satellite provider. They said yes, so now we're calling the satellite operator, their network operations center, and we'll see if they're happy with it, and then we can start operating with that. So I got it aligned a lot better than it was before. We got the transmit on, we did our compression test, and everything was looking good. Our cross polarity was a little off. Okay, so I went to go loosen the L&B part at the front, and it snapped the head of the bolt off. I was not putting any extreme force on this, so it is one thing after another with this uplink. Okay, so last time I tried to loosen the bolt on this and the head snapped off, which means that the bolt is kind of stuck in there. So I have some WD-40. I'm gonna spray it in there. Let's hope that kind of loosens that up. I've got my pliers, grips, things. We could try to get that out. If I need to, I can shave down some of the sides of that bolt so that way I get a little bit more grip to try to get it out, and yeah, hopefully this works. I have to get this project done today. All right, now we wait, and hopefully this stuff will loosen that up and we can go from there. All right. Both of these are frozen in there. So put my hard hat on because I needed some extra sun protection, and I don't know where my floppy hat is. I think it's at home. Anyways, so I think I've tapped one hole, drilled it out, tapped it, put threads on it basically. I need to go back to Lowe's and get some bolts for the right size. The other thing is, the other side still has part of a bolt sticking out. I need to get a little hacksaw to cut that off and then drill that out. And I just realized I didn't grab the extra batteries from work, from the office. I have 2 more bolts, different sizes, or different lengths. So let's see if the ones that I tapped here fit. Oh, it fits. And it feels like it threads. Okay, this is the first time I've done this, so bear with me on this. It's a little bit of a minor miracle that it actually works as expected. There's not an enormous amount of threading. Okay, so the little 1/2 inchers are the ones that are going to work. Excellent. Okay, so I have one bolt ready. I have to get rid of this one. It's still sticking up, so I have a hacksaw, and I've got to drill it out, tap it, reseat this whole part. So I have this little adapter, or this little part that's going to go on top that will hold the top of the feed horn in place. After I drilled the holes out, the holes on here are too small. So I am trying to make the holes bigger. I now have the XR3, the satellite finder, and my spectrum analyzer connected to the LMB, which is the receive side of this dish. So let's see if I can peek it on my own before I call the knock, and see if we can get this done this way. Let's see if I twist it. If I twist it this way, what did I do? 17.2. So let's go back that way. 17.8. I'm on the phone with our network operations center, so
occasional use access.
let's see how we get this
To report service problems,
going. So we're going to cross pole, check our cross polarity,
press 3.
and make sure that we are either vertical or horizontal. So we want to make sure we're like that. And they're going to have me go up on a test frequency. And once we're on that test frequency, and we're transmitting a carrier wave, just a single like tone basically.
Still there, Marcos?
Yep, still here.
Okay, cool. Hopefully, I know they're staffed 24/7, 365. But, hi, Mike. This is Mike with Link Up Communications in Inglewood, Colorado. Need to work on a cross pole here with a client who's out in the field.
Small movement, same direction, done.
Okay, opposite way.
Opposite direction, small movement. Done.
Okay, let's try locking the polarity here, and let's adjust your azimuth.
Excellent. Thank you so much for your help.
Yeah, I'm glad to help. Y'all have a great evening.
Thank you. You have a great Thanksgiving too.
Hey, you as well. Enjoy your family.
Thank you.
Take care.
Thanks. Hey, Marcos?
Yes, Mike.
What kind of dish and amplifier have you got?
The dish
Bring
is
it
a.
down for the record thing.
It's done. Oh my gosh, it's done. Finally. Okay, so this project is like 99% done. I mean, in technically, this whole thing will have to be also done at Santa Ana at the main uplink up there. But this one is up. It's on SES-2, which is our new satellite that we are going to be transitioning to. And yeah, we should be good to go now. I'm going to be giving my affiliates 2 weeks notice, December 9th. This video should be out before then, to transition their downlinks to the new downlink, new frequency, new satellite. And yeah, we should be good to go from there. And just in time for Thanksgiving holiday, because that's tomorrow. Man, what a pain this project was. I learned a lot. I really did. Some things I will never do again in the way that I went about doing this project. So yeah, this was a very good learning process for me and a learning experience for me. And I hope that it helps you, at least provides a little bit of insight as to what goes on with satellite delivery. I am so done with this part. But we're going to have to do this again when we are ready to turn up the Santa Ana, or repoint the Santa Ana uplinks. So anyways, that all said and done, thank you so much for watching. Thank you for being here for this project and this video. I learned a lot. I hope you at least got something out of this. And I thank you for watching. Okay, well then, until next time, stay safe, stay healthy, and we'll see you in the next video, whatever that major project ends up being. Maybe it's gonna be a Palomar generator, hopefully not. Okay, anyways, all right, bye.